Welcome back to our video series about the science, philosophy, and metaphysics behind information field technology. This is Chapter 6. It is about generalized information field entanglement. This chapter is about so-called generalized quantum entanglement, which is based on a generalized form of quantum theory proposed by Professor Harold Volek and further developed by Romer and Atmansbacher. In the generalized form of quantum theory, a whole set of formal constraints such as the existence of a Hilbert space is discarded, and instead we concentrate on the most important irreducible condition required to obtain a quantum theory. This is the so-called non-commutativity of the underlying operators. It means that quantum theory depends on the order, that is, on the commutativity of certain operators. This was first realized by Werner Heisenberg after his physician sent him from Munich to Helgoland to cure his allergy, his hay fever. While he was hiking and climbing there, the thought suddenly came to him whether it would yield the same results if one measures first the impulse and then the location, or first the location and then the impulse. He came to the clear conclusion that it would indeed make a difference. So the commutator of momentum and location is not equal to 0. X times p minus p times x is not equal to 0. This leads to the well-known Heisenberg uncertainty principle, which also plays an important role for our work. As soon as there is non-compatibility between local and global observables, which cannot be interchanged, where the order of measurement plays a role, you encounter the phenomenon of generalized quantum entanglement. For example, if several people are attending a lecture, there are already properties of the relations between the individual attendees, a complex system with limitations, and global properties, meaning some properties that apply to all and properties that apply to the individual. These properties do not commute with each other. This fact can be represented and formalized so that one can also represent a quantum theory for such macroscopic objects and properties that goes beyond physics. This can involve entanglement between people or between mental states and physical states, for example, in psychosomatics. This generalized quantum theory was published at a high scientific level. This is also the basis for discussing entanglements between the information field, as in the information field of a particular individual, and a physical process, such as a physical noise generator. So this is about generalized quantum entanglement, which cannot be resolved by the microscopic chaos of Brownian molecular motion or by high temperature. Volek has examined generalized quantum entanglement in connection with quantum teleportation, which was described in more detail in an earlier chapter. The point was that it successfully entangled systems in such a way that quantum information could be teleported across them. Now let us take a closer look at this connection. In this kind of quadrupole, we can find orthogonal entanglements. For example, there could be a patient at the bottom here and the therapist at the top. Generalized quantum entanglement is regularly found between therapists and patients. This can go as far as a therapist feeling similar things in their relationship to a patient as the patient does. If the patient is not feeling well, the therapist may also feel unwell. In psychotherapy, this is called transference and countertransference, the latter meaning it works in both ways. This can lead to a complex global system where the patient-therapist global system is in a state that does not commutate with the state of the two individuals. This in turn can lead to entanglement correlations, which are called synchronicities. One of the most famous cases of synchronicity was documented by the famous psychiatrist Carl Gustav Jung. He once woke up in the middle of the night feeling a stabbing pain in the back of his head. This was so startling for him that he looked at the clock and noted that it was 3:30 in the morning. He couldn't fall asleep for a while. The next day, he learned that one of his patients had taken his own life with a shot through the back of the head at that exact time, a drastic form of entanglement. In quantum teleportation, two photons are originally entangled with each other by a common origin. This is a so-called Einstein-Podolsky-Rosen pair, here called entanglement number 2. At the same time, photon A is entangled with photon C by a Bell measurement. In this example, via the photon A, the two photons C and B are also indirectly entangled with each other. The two photons A, B a so-called EPR pair, are entangled. If we now entangle the photon C with the photon A by a so-called Bell measurement, a short circuit and information transfer can occur between B and C. However, only under one condition, namely that at the same time the result of the Bell measurement is transmitted through a classic information transfer channel on the left. So, the information which resulted from the Bell measurement, measured only at the global system A and C, is transferred to the left, for example by an email, and the moment it arrives at B, such a transfer of information takes place. The same structurally identical diagram can be found here. This is the model of so-called quantum teleportation, as it is generally represented. Here, we have basically the same setup, namely the photons A and B, which are quantum entangled. They are a so-called EPR, or Einstein-Podolsky-Rosen pair. Here, by a so-called Bell measurement, an input photon C is entangled with the photon A. We can see that the information content of C is transferred to the photon B, but only if 2 bits are transferred from A to B here. This is the result of the so-called Bell measurement, which entangled C and A with each other. Subsequently, a transformation of B is taking place. This means that the information content of C is modulated onto B. Austrian physicist and Nobel laureate Anton Zeilinger performed this experiment many years ago, linking the observatory on the island of Tenerife at the top of the Tide crater with the observatory at La Palma, spanning a distance of 147 kilometers. In the meantime, this is no longer a world record. This principle is demonstrated here once again based on the concept of orthogonal entanglement, or so-called orthogonal complementarity. The structural equality of these two pictures is to be noted here. A circular exchange of information is taking place. This can now be applied to the principle of entanglement of a noise generator with information fields, resulting in this diagram. The physical noise generator is system A, while the bioenergetic field of a client, of a person, is system B. These two are entangled by intention as a so-called EPR pair. This means that by the conscious intention of the experimenter, the physical noise generator is entangled with the client or with their bioenergetic field in such a way that it shows events synchronous to the bioenergetic system B. This is based on the findings of the PAIR lab, whose experiments have been described in more detail in a previous chapter. At the same time, analogous to a Bell measurement, the individual information field is entangled with system A, so that we arrive at a double entanglement. If information is transferred in the classic way through so-called database analysis, an information short circuit occurs between the individual information field, system C, and the bioenergetic field of the person, so that information from the information field can be transferred into the bioenergetic system of the client. The goal is thus to analyze information in the information field in order to promote the well-being or holistic health of an individual via a noise generator and making a database of information patterns available to the system. In this case, the principle of the quantum teleportation is analogous to what occurs in the entanglement between the physical noise generator, an individual, and the information field, which is not local, so that a local transfer or activation of the information field for person B can occur.